Okay, guys, so I already have Algebra 2 right here, but today is Thursday, May 1st. Crazy. So that means tomorrow is Friday. That's going to be when everything from this week is due. We won't have any new exit tickets today. Today, the plan is just to go over what we've been learning this week, kind of a bit of a review. I also would like to introduce the last method of solving systems of equations that we kind of hinted at yesterday, which is elimination. But before we do that, we're going to review substitution today. So it is day 24. Write that up here too. Day 24. All right. So guys, this is something crazy to think about. Not counting today, we only have 4 class days until finals week left. Next week is the last real week of class. Finals week, the way that we do that, at least in this room, is usually Monday. I give you the practice final, and I give you all the different options for your final. So I usually let you choose between taking a test, open note, just like everything is in here, or I'll have some projects to choose from if you don't love taking tests. So be looking forward to that. I'll be coming up with those this next week. But what's kind of nice about the way I like to lay out finals is the day you take it, Monday I introduce the ideas. Whenever you decide to take it, whenever you finish, you're done. So some people even take it on Monday and they don't have to come back the rest of the week. So this term's almost over. It's just like crazy. It's gone so fast. But we'll talk more about that as the time gets closer, just looking ahead. So let's look at this worksheet. Substitution. So we started, hi Randy, we started learning about how to solve by graphing. Now, whenever we solve a system of equation by graphing, we graph both of the lines. We see where those lines cross. Whatever point they cross at, that's our answer. Whenever we start using substitution, we don't use a graph. Now, we're looking just at the numbers and the variables. So let's look at number 1 together. And I would love your participation in guiding me through this one. So starting with number 1, I've got 2 equations. Y equals 3x plus 4 and y equals 2x plus 2. What would be a good first step to solving for at least one of my variables using substitution? Yes. Okay, so what we have here is a solved answer for y. I know that y is 2x plus 2. I also know that y is 3x plus 4. So really, I can switch these out for each other. I can substitute either way and get rid of the y. So I'm going to highlight the different values we could do. Y is equal to y. Both of these second half of the equation, 3x plus 4 and 2x plus 2, are equal to y as well. So what I can do here is set this 3x plus 4 equal to 2x plus 2 because they are both equal to y, so they're equal to each other. So let's go ahead and bring these over. I'm going to write 3x plus 4 equals 2x plus 2. Now, could I also do 2x plus 2 equals 3x plus 4? Yes, absolutely. You can do it in either order. All we're doing is taking the second half from both equations, all the stuff without the y, and we're putting an equal sign in between those two. That's all we do for the first step. So once we have an equation where we don't have any y's, we just have x, now we can try to solve for x. So I'm going to write here as my first step, step 1. And we've got the second halves equal to each other. Now we're going to solve for x first. So whenever we have an equation like this, you'll notice that we do have x's. We've got variables on both sides of the equal sign. So whenever we're trying to solve for x, I'm going to draw a line right down the middle of that equal sign to separate my sides. When we're trying to solve for x, I need my equation to be rearranged in a way that I have x equals something. I cannot do that if there's x's on both sides. So how can I rearrange this equation to get all my x's on the same side? What could I do? We want to combine our like terms, meaning our terms that both have the same variables. So I've got a 3x and a 2x. How do I get these on the same side? Multiply. We're not going to multiply yet. It's a really good idea, though. Yes. Before we have them on the same side, we're just thinking of these as terms. We're not trying to separate them yet. I have 3 x's over here. I have 2 x's over here. Let's subtract these 2 x's from this side to get rid of them. And anything I do on one side of the equation, I need to do it again on the other side. So I subtracted 2x here. I also need to subtract 2x here. So on this side of the equation with 2x, when I subtract 2x, what happens? They cancel out. 2x minus 2x is 0. There's no x's left. So we don't need to write 0. We just cross it off. It's canceled. It's gone. Now what do? Bring everything down below this line. So I have my equal sign in the same spot. And this is where I saw a few mistakes on our exit ticket yesterday. When we bring things down, I saw some of us accidentally bring different things on wrong sides of the equation. So it might not be a bad idea to start with your equal sign and then bring everything down and make sure it's on the correct side. So I have my equal sign. On this side, all I have left is 2. So I'm going to bring down that 2 here. What needs to be brought down on the left side? Yes, 3x minus 2x gives us 1x. So I'm just going to write x and then plus 4. So I brought everything down. Now it's like I have a whole new equation. X plus 4 equals 2. We're still trying to solve for x. So again, we want to get rid of anything that is not x. Oh, on this side, I have x plus 4. What do I need to get rid of? The 4. Since it's plus 4, how do I get rid of that? Subtract 4. So we'll do minus 4. Where else do I need to subtract 4? Under the 2. If I do something on one side, I have to do it on the other to keep my equation even and balanced. So I'm subtracting 4 from both sides. Now I'm starting with a plus 4. I take 4 away. What's left over here? Just my x. My 4's will cancel. So I'm going to bring down my x, my equals. What's 2 minus 4? Negative 2. Okay, so just like that, we've solved for x. X equals -2. Perfect. Perfect. Okay, so far all we've done is set the right sides of the equations equal to each other. We solved for x. So, now that we have solved for x, we still need to solve for y. So how do we do that? Yes, I can choose either one of these original equations, the top one or the bottom one. It doesn't matter. We'll get the same answer regardless. And I'm going to rewrite it, but instead of writing 3x plus 4 or 2x plus 2, I'm going to be putting -2 for x. So let's start with, I'll use the top equation just because that's the one I'm seeing and looking at. So the step 2 is now solve for y by plugging in the x value we just found. So I'm going to write that top one. Y equals 3x plus 4. 3, I will leave a space for x, plus 4. Okay. And we just solved for x. X is -2. So I am just going to take my -2 and put it where I originally had x. Now remember, when we have a variable right next to a number, just a review of this, that means we're multiplying. 3x means 3 times x. So 3 and -2, we're going to start by multiplying those. 3 times -2. So to start, what is 3 times -2? -6. So I'll cross that off and write -6 instead. Y equals -6. I'll bring down my plus 4. What do I do now?
Add them,
Yeah, add them together. What is -6 plus 4? -2. -2. So we have our x value, it's -2. We have our y value, it's also -2. We've solved the system. That's all there is to it. Now, if you wanted to write this as a coordinate, we would just put a set of parentheses here. Remember, the first value is our x value, the second is the y, and we will just write those -2's in our coordinate. -2 is our x, -2 is our y, and that's our answer. Okay. So that's a little review of how we do substitution. There it is. We're setting the equations equal to each other, removing the y to solve for x. Once we have x, we can solve for y by using that value in one of the original equations. Okay, so let's do one more of those together, and then I'm going to have you guys try a bunch more on your own, make sure we all got it, make sure we feel good about it, okay? And if not, we can talk more. Really, I want you guys to tell me if there's things that you're not quite getting. If you're not sure where I got certain things, interrupt me, tell me. I love it when you ask questions. It helps. It helps you, it helps your classmates, because I'm sure if you are asking something or not sure about something, somebody else is probably feeling the same way. Okay. Are we ready to do number 2? Or do we have any questions before number 2?
I do.
Yes.
So either 4 for the y.
Yes, absolutely. You can use either of the equations to solve for y. So like if I wanted to, instead of 3x plus 4, I could have done y equals 2x plus 2. If I plug in my -2, I will get, y equals 2 times -2 is -4 plus 2. And -4 plus 2 is also -2. So you'll get the same answer no matter which one you use. Yeah. Awesome. Perfect. That works. That works. Okay. Let's go ahead and look at number 2 then. Now I have y equals 2x minus 2 and y equals x minus 2. So how will I start this problem? 2x minus 2
Equals x minus 2.
yes, equals x minus 2. So all we did is take the second half of each equation and we set them beside each other with an equal sign in between. That's all we did. Okay. How can I solve for x? What do I need to do? Absolutely. We want to combine our like terms. I have 2x on this side. I have x on this side. I want to subtract one of those and get them both to the same side. So let's subtract x from both sides. And again, if it helps, draw that little line in between your equal sign. Sometimes it just helps give you a little visual to see what's happening. Okay, so x minus x, what happens here? They cancel out. There's nothing left. And over on my other side here, 2x minus x. If I have 2 x's and then I take one of them away, how many will I have left? 1x. Good. So whenever we do this subtraction, we will have 1x left, but we're just going to write x. Is anybody confused about why I just wrote x and I didn't write 1x? Yeah. Anytime that there is a variable like x and there's no number in front of it, that number is always assumed to be 1. Because if I'm looking here, this is, I can ask myself, how many x's did I write here? Well, 1. There's only 1. So there's 1x. All right, what else do I need to do? Yes, bring down -2, bring down equals -2. Bringing everything down. Okay. So, where do I go from here? Add 2 to both sides. Now, do I want to, well, I guess it won't matter which way I do it. I'm going to add 2 over here. I'm going to add 2 over here. I was going to ask which 2 am I adding to first, but it wouldn't make a difference. Okay, so what is going to happen at this step?
Everything cancels out.
Oh my gosh, everything cancels out. Now, if this happens, don't freak out. Here's what's going to go on here. Your -2 and your +2 cancel out. When something cancels out, it just means that it equals 0. We don't need to write the 0 here because we just have x left. Bring down our equal sign. Now -2 and +2 cancel again. So what's going on here? 0. Remember that if something cancels, it means that they add up to 0. So it doesn't mean that there's no answer for x. It means that x equals 0. So that is our x value. We've got that. So now that we have our x, how do we solve for y? Plug the x in for one of these equations. So I'm going to use the bottom one because it looks a little easier. Y equals x minus 2. And since I found out that x is 0, I'm going to put 0 for x. What do I do next? Yeah, really. I mean, I'm just going to bring all that down. Y equals, well, 0 minus 2, it's negative 2. So x is 0, y is negative 2. If I wanted to write this as a coordinate, how would I do that?
0.
Perfect. 0, negative 2. The x comes first, then the y. Perfect, perfect, perfect. That's our answer. You did the opposite of that?
Yeah, but
Y2. Say that again. 2, 4, negative 2. Where'd you get the 4? So whenever you solve for x, did you get x equals 4? Okay, so let's see how you got that. Whenever you started your original problem, what did you set equal to each other? Did you do the same thing as me? Okay, 2x minus 2 equals x minus 2. And then what did you do first after that? Can I see your paper? I bet that would be more helpful. Here, let me pause and take a look at yours. All right. Any burning questions? Yes. 11 or 12? Yes. Absolutely. Let's go ahead and look at 11. Ooh, this is a fun one. 11 and 12. So, look at this. Number 11. My first equation says y equals 3. My second one says y equals negative 2x plus 1. Without me telling you what to do, does anybody have any ideas of what we would do here? Y equals 3. They've already solved for y here. So you're just trying to find x. Yes, if they already give you y equals 3, they're telling you that y equals 3. So whenever we are solving for the next variable, I know that I can replace y right here with the y value they already gave me, 3. Yes. So whenever we do this, I'll write it out for you. We would do y equals, well, y is 3. So 3 equals negative 2x plus 1. This one looks funny, but it's actually going to be way easier to solve because you already have your y solved. So let's go through and solve this. 3 equals negative 2x plus 1. What would I do first? Yes, subtract the 1 from this side. Now, where else do I need to subtract 1? Under the 3. Remember, here's our equal sign. Whenever I do something on one side of that equal sign, I have to do it on the other as well. So let's subtract 1 from 3. What happens to my plus 1 and minus 1? They cancel out. Good. And 3 minus 1 is 2. I'll bring down my equal sign. And when we bring things down, this was another mistake I saw on our exit ticket. Don't lose your negative signs. This is 2 equals negative 2x. Don't lose that negative sign. So now I need to still do one more thing because I'm trying to solve for x. Yes, this means negative 2 times x. We want to do the opposite and divide by negative 2 to get rid of it. So I need to do that on both sides as well. And what happens over here with my negative 2's? They cancel out because negative 2 divided by negative 2 is 1. And if I have 1 in front of my x, I don't need to write the 1. I can just say x is left. I'll bring down my equal sign. And what is positive 2 divided by negative 2? Negative 1. So x equals negative 1. Thank you for pointing that one out, Cody. Appreciate it. So if our x equals negative 1, we've got that solved. Do we need to do anything to solve for y? No, they already solved it for us. Y equals 3. So if I wanted to write this as a coordinate, what would that coordinate be? Perfect. Negative 1, 3. X comes first, then the y. There we go. Okay, guys. Let's see. And as you're going through these, if there's any other that look kind of funky like that, feel free to point them out and we can absolutely go through them together. Do we have any other questions before I have you guys try these on your own again? Okay, so here's what I would like you to do. This worksheet has 20 problems on it. I'm going to set a good 20-minute timer, and during that 20 minutes, I want you to go through this and just do as many of them as you can. There is an answer key attached to the back, so you can check your answers and see if you got something right or wrong. And when that 20 minutes is up, we'll go through any questions that you guys come up with as you're solving these on your own. And I will be around to help you guys one-on-one, but also please feel free to work with each other. I see the most learning happen, honestly, when I see you guys work together. So feel free to do that as well. But I will go ahead and set that timer, let you guys do these. And if any of you have things that are due tomorrow that are not done and need to get done, feel free to use this time to work on those things as well. But anyway, I'll be around to come and help, and I'm going to pause our recording. So you guys have been working on these now for quite a while. What I would like to do is have you guys tell me which problems you want to see, and we'll go by request because I'm sure that there are certain ones that gave you guys trouble versus others. So I would like to just open the floor at this point. We've done number 1, number 2, and number 11 together so far. Are there any other numbers that any of you would like to see worked out?
Number 18.
Number 18, you got it. Okay, so we're going to look at number 18. All right. So for number 18, we have y equals x plus 4 and y equals 3x plus 12. Whenever we're using substitution to solve, that first step is always going to be to take the other side here, the right side of both equations, and we're going to set those equal to each other. We're just putting an equal sign in between them. So let's go ahead and write x plus 4 equals 3x plus 12. You could also put 3x plus 12 first equals x plus 4. Both of them will give you the same answer. So I've got my other sides equal to each other. And we're going to solve for x first. So let's see. I've got my terms with x's right here. What would be a good first step to solving for x in this problem?
I would subtract the x.
Yeah, that's a great way to start. Let's subtract the x from this side and the other side so that we can get all the x's on the same side of the equal sign. So minus x minus x. Okay, what happens to x minus x? They cancel out. They are gone. And now we want to start bringing everything down below the line. I have 4 over here left. I have my equal sign. I have 3x, but then take an x away, plus 12. So what is 3x? Take away 1x. 2x. And I'll bring down my plus 12. Okay, so at this point, something that I've noticed again on a few of your papers that I think would be helpful to talk about is if I start over here on the left side of my problem where I subtracted x, I took it away from the left side. Whenever you move to the next step, is it going to help to take away more from the left side? If I subtract 4 next, is that helpful? No, this is not helpful. If I started on the left side, sometimes it's really helpful to make sure that we're kind of switching sides as we go. I got rid of an x and I only have 4 left over here. We want to take away from the side that has more stuff going on. I have 2x plus 12 over here. I have a lot that I can get rid of. Over here, I have 4 all by itself. We're not going to take away 4. That wouldn't help us. So looking over here now, 4 equals 2x plus 12. What would my next step be?
Minus 12.
Minus 12. Perfect. And remember, if I do something on one side of my equation, I've got to do the same thing on the other side as well. So I subtracted 12 here. I need to subtract 12 here as well. And now this is the step that we took. Okay, so what happens to my 12s? They cancel. And now let's start bringing everything down. On my right side of the equation, all that's left is 2 times x. I'm going to bring that down. I'm going to bring down my equal sign. And on the left side, I have 4 minus 12. What is 4 minus 12? Negative 8. So now I have negative 8 equals 2 times x. What's the last thing I need to do? Divide. Since I have x over here and it's being multiplied by 2, if I want to get rid of that times 2, I need to do the opposite of multiply. I need to divide by 2. And remember again, if I do something on one side of the equation, I have to do it to the other to keep them balanced. So, what happens at this step? My 2's will cancel out, and I'll be left with just x by itself now. Yes. Bring down my equal sign. Negative 8 divided by 2 is negative 4. So we've solved for x. We've got x equals negative 4. That is perfect. So once we've solved for x, which we have done here, we're not done yet. We need to also solve for y. How do I solve for y next? I'm going to use one of these equations, and I'm going to use the top one because it has less numbers to mess with. And we're just going to rewrite that equation, but instead of x plus 4, we know what x is. It's negative 4. So I'm going to write negative 4 plus 4. Y equals, that's where x was, plus 4. Instead of x, we're writing negative 4 plus 4. Okay, now what is negative 4 plus 4? 0. So our y equals 0. X is negative 4, y is 0. Those are our answers. That's it. If we wanted to write this as a coordinate, we would put the x first and then the y second. So negative 4, 0. Okay. There we go. All right, any questions about that one? Okay, what other numbers on this worksheet would we like to see? Number 16. Okay, let's go ahead and look at 16. Number 16. This is a good one. Y equals negative 4x minus 12 and y equals 2x. Okay. So, first things first, we want to solve for x. How do we start this problem? 2x. Perfect. Equals the other side here. Negative 4x minus 12. We're just taking the second half of each equation, rewriting them with an equal sign in between. Okay. Now, I have an equation where on the right side of my equal sign, I have a couple of things going on. I've got negative 4 times x, and I have minus 12. On the left side, all I have is 2 times x. When I see that my right side has a lot more going on that needs to be rearranged and gotten rid of, that's the side I want to start working with first. There's more on this side. Let's get rid of the part with more. So, looking at my right side here, what should I do? So we have negative 4x plus, or minus 12. Okay, I have x's that need to be combined. And then I also have here a number without an x. So if I added 12 to both sides, would that help us get closer to solving for x?
You said times it?
Times what?
No, we're gonna add 4 on each side.
Yes, we want to get our like terms together. We have 2x, we have minus 4x. We're going to add 4x to both sides. Remember that equal sign separates the sides. So I need to do that on both sides. Okay, what happens to minus 4x and plus 4x? They cancel out. I'm going to bring down that equal sign. Okay, and what's 2x plus 4x? 6x. So 6x equals negative 12. Just bringing down those numbers. Okay, so now I have 6x, or 6 times x, equals negative 12. How do I get x by itself? We're going to divide by what? By 6. And if I do something on one side, have to do it to the other. So 6 divided by 6 is 1. 1x is just x. Those 6's cancel out essentially. And that's going to leave us with an x all by itself. Equals negative 12 divided by 6 is negative 2. So there's our x value. X is negative 2. Okay. Now how do I solve for y? Yeah, we're going to just plug in this value, this negative 2, and we're going to replace the x in one of these equations. I'm going to use the bottom equation because that looks a lot easier. Y equals 2 times x. So let's just rewrite that. Y equals 2 times x. Instead of 2 times x, we have an x value. What is that x value? Negative 2. So y equals 2 times negative 2. What is 2 times negative 2? Negative 4. That is our answer for y. X is negative 2, y is negative 4. If we wrote it as a coordinate, we'd have negative 2, negative 4, x and y. There we go. All right, guys. We could absolutely do more, and we absolutely can, but it is 10:33, and I want to make sure I still give you guys your break today. So I'm going to say go ahead and have yourselves a little break. Let me see. What time come back? Let's say we'll come back by about 10:55, 10:50, 55-ish. That should give you plenty of time to do anything you need to do. And I'll see you after the break. All right, we are back from our break. So before we go on to talk about the third method, elimination, does anyone have any other problems on this worksheet that they would like to go through as a class before we move on? Number 20. All right, let's go to number 20. Okay. So number 20, I have y equals negative 3x plus 10 and y equals 4. So we've already got our y value. Y is 4. Perfect. What can I do now to solve for x? How can I set this up? That's right. I'm going to take my equation that has x in it, and I am going to replace y with 4. We're going to substitute it. So instead of y equals negative 3x plus 10, we're going to use the value they gave us. 4 equals negative 3x plus 10. Okay. So now that we've got that set up, what steps steps could we take to solve for x? Minus 10 on each side. There's the equal sign. So I'm going to subtract 10 over here as well. Okay. What happens at this step?
4 minus 10. 10's cancel.
Yeah, my 10's cancel. 4 minus 10, -6. Good. I'll bring everything down. Equal sign, and over here all I have left is -3 times x. Okay, I've just got one more step. Perfect. We'll divide by -3 on both sides. So my -3's will cancel out, and that is going to leave me with an x all by itself. We'll bring down the equal sign, and now I have -6 divided by -3. And we're going to get +2. So my x is 2. Do we need to solve for y? No, they already did it for us. Whenever we have a second equation that just says y equals a number, y is already solved for. So x is 2, y is 4. And if we wanted to write this as a coordinate, how would I do that? What do I write here? 2 is my x, that comes first. 4 is my y. Good. And that would be my answer. There we go. Okay. Any other questions on this worksheet? I'll give you guys a minute to look through it just in case you have another one. All right. Are we ready to move on? Okay, so we've got solving by graphing. We've learned solving by substitution. So now let's pull out our notes, and we are going to take a note about how to solve by elimination. So let me grab a notebook. Now, my plan today is to introduce this method to you. If you get it on the first day, if it makes perfect sense, that is amazing. Consider yourself ahead of the game. We are not going to have an exit ticket over elimination until next week, so don't worry if you're not quite 100% confident about this method just yet. Today, we're just introducing it. We will practice more on it next week. Yes, yes. So let me pull that out. Thank you for reminding me. Grab that. So if you don't have yesterday's notes, basically what we did, I'll give everybody a minute to write this down. We made a list of the 3 methods. This is from yesterday. For solving systems of equations. The first method was to solve by graphing. So we wrote a little description of that where we just graph both of the equations, and then the intersection gives us our answer. It's just the point where the lines are crossing. Now the second one is what we've just been doing, solving by substitution. So to give a little bit of a description there, I'm going to write y equals mx plus b, and I'm going to write it again, y equals mx plus b. Because typically we're going to see two equations written in this form. And to do substitution, we take the second half of both equations and we just set them equal to each other. So this is what we kind of did here. We're setting those sides equal to each other, and we solve for x. Once we've solved for x, that's when we substitute the x value we found into either one of the original equations. So let's see, I'm going to write whatever we got for x, y equals m there's where x was, plus b. So that x goes in here, and we solve for y. So this is sort of a little overview of the process we do in substitution. First we solve for x, then we solve for y. Unless, of course, one of the variables is already solved for, which we saw in examples like number 20. We already had y solved. So as you're copying that down, I'm going to start writing something different down here for elimination. I'll pause this to give everybody a minute to write this down. If you don't have it yet, this is a good thing to have in your notes. And then we'll move on to talking about elimination. All right, so now we're going to talk about elimination. So the best way to show you this, I think, is by using an example. I'm going to pull this to the side. We will fill out more information on elimination once we learn the technique. So
Don't they still list the same? They list the same as y x plus b.
yes, so whenever we're using elimination, you're going to notice here, this is a totally different type of equation. It's written in a different form, but we're still going to take similar steps. We're still going to solve for an x value and a y value. So I'm going to show you that different form. Let me title my note page. Algebra 2, Unit 3. And today is day 24. So I'm going to write day 24. Okay. And this is page 1. And we will title this page Elimination. So elimination. We are used to seeing equations right now in the form y equals mx plus b. That's where we have a slope and a y-intercept. So it's called slope-intercept form. When we are using elimination, you're going to see your equations in a different kind of form. And that form is called standard form. So I'm going to start by giving you two equations written in standard form. For example, 9x plus 18y equals 9. And the second equation, negative 5x minus 9y equals negative 1. So whenever we are using this process called elimination, we are actually going to start by choosing one of the variables, either x or y, and we are going to eliminate, completely get rid of one of these variables. And I'm going to show you how we do that. So first thing I'm going to look at is the numbers attached to both variable. I have 9x in the first equation. I have negative 5x in the second equation. I have positive 18y in my first equation, and I have negative 9y in the second equation. So my first thought when I'm looking at this is, well, whenever I see the y's, 9 and 18 are similar, because if I took 9 times 2, I would get 18. So something that I think is crazy and it feels unnatural at first is I can take my entire equation here and I can multiply the whole thing. So what I'm going to do is I'm going to try to match up this 9, because I have a 9 here. I'm going to match it up to this 18 here so that my y's have the same number but different signs. So I'm going to multiply everything by 2. It's just like distribution. I'll be multiplying negative 1 times 2. I'll be multiplying negative 9 times 2 and the negative 5 times 2. And we're going to give ourselves a new equation. So first, what is negative 5x times 2? Negative 10x. Next, negative 9y times 2. Yes, negative 18y. And I still need to bring over my equal sign. That's what's next. And negative 1 times 2. Negative 2. Good. Okay, so I have my second equation here rewritten because we multiplied everything by 2. So what I'm going to do now is I'm going to also write my first equation again over here right on top of this equation so that they're lined up really nicely. So on my first one, I have 9x plus 18y equals 9. Yes, yes. So what we're going to do next is, since these are nicely stacked on top of each other, I'm actually going to draw a big line underneath, and I'm going to treat this like a big addition problem. I'm going to add these two equations together. So 9x plus negative 10x, or we could think of this as 9x minus 10x. What would that give us? Negative 1x. Perfect. I could write negative 1x. I could write negative x. Either one. I'm going to write negative 1x for now. Now I have 18y minus 18y. 0, nothing. They cancel. This is where the elimination happens. Instead of writing 0, we're going to cross these off because we've just eliminated the y's. Now I have my equal signs. I'm just going to bring those down. And my last step is the 9 plus -2, or 9 minus 2. 7. Positive 7. So now I have -1x equals positive 7. I'm almost there. How do I solve for x? Divide by -1. Okay, those cancel, and now I've got a positive x. I bring down my equal sign. 7 divided by -1, what will that give me? -7. So we chose essentially to cancel the y's first. We eliminated the y's by multiplying the whole equation to get the numbers to match. And now we have our x value. So now we got to find y. Yeah, we can either, there's a couple things we can do. We can now switch back to the substitution method. We could plug in our x value, and we could do it that way. Sometimes that feels easier. Or we could try to eliminate the x value next. Now, if we wanted to do that, 9x and -5x, those may be a little bit trickier to get to match up. You may need to do some bigger multiplying here and do both equations. I would recommend at this point plugging your x back into one of the problems. That's what I would recommend doing. So let's start with that. And I don't like negative numbers, so let's use the first equation. So what I'm going to do now is just rewrite that first equation, 9x. I'm going to leave a space for x, plus 18y equals 9. You can use either equation, yes. If you wanted to use the bottom one, you absolutely could. So instead of 9 times x, what am I writing for x? -7. That's the x value we found. So now we just need to solve for y. So what is 9 times -7? -63. And then I'm going to bring everything down. -63 plus 18y equals 9. Now remember, our goal is to get y by itself. So we need to start getting rid of things that are keeping y from being by itself. Yes, we're going to add 63 to both sides of the equation. Okay, so my 63s will cancel. I'm going to bring down 18y. I'm going to bring down equals. And what is 9 plus 63? 72. And now we just have one more step. Yes, divide by 18. On both sides. Those 18s will cancel, leaving me with y by itself. Bring down the equal sign, and now we just need to do 72 divided by 18. And let's see, what does that give us? 4. Perfect. So now we have x equals -7, y equals 4. And if we wanted to write it as a coordinate, again, we could do that. Which value comes first? X. So -7, comma, 4. That's our y. There we go. So we are choosing one of the variables to eliminate. You could eliminate the y first. You could eliminate the x first. I would always just recommend doing whichever looks easier, whichever number has more similarities. But that's our first example, and we're going to run through just a few more. So that we can kind of see that process over again. You like this one better? Well, good. Everybody's got preferences. It's funny that some people hate this method and some people love it. So let's look at one where we don't start with negatives in the equation. This one was nice because I started with a -9y so that when I added them together, +18 and -18 cancel. So here's another example. And can I move this, or is anybody still writing? I don't want to move it too quick. Okay, scooch that up. So let's try this one. 10x plus 2y equals -8, and 20x plus 5y equals -25. So, looking at both equations, which variable do we want to try to match up? You can do either one. I'd say x, yes, because 10 and 20 are very similar. They're both multiples of 10. 10 times what would give me 20? 10 times 2. So let's start by multiplying the top equation. And now here's where it gets tricky. If I multiply by 2, I'll have 20x. If I do 20x plus 20x, is that going to cancel my x's? No, that's going to give me 40x. What do I need to do to make them cancel? Yes, we're going to multiply by -2 so that I get -20. That way, I'll have -20 plus +20, and then they will cancel. They need to be the opposite sign. So let's multiply everything in this equation by -2. So positive 10x times -2 gives us -20x plus 2y times -2. What does that give me? Perfect, -4y. Bring over my equal sign. And -8 times -2, what is that? 16, positive 16. Perfect. So I have got my first equation. I just need to rewrite my second one underneath. So 20x plus 5y equals -25. And now we're just going to add the equations together. Now this one's really nice because you're not going to have to do a whole lot to solve for y in a minute. What happens to my x values? They cancel. We eliminated them. They're gone. -20, positive 20, they cancel. Now my y's, I have -4y plus 5y. 1y. Instead of 1y, we're just going to write y. I've already got y all by itself. I'll bring down my equal sign. And 16 minus 25, what is that? -9. We solved for y. Y equals -9. Okay. So now that I have a y value, which equation do we want to try to use for solving for x? It doesn't matter which. Let's do the top one. The numbers are smaller. So I got my y value. Now I'm just going to rewrite my top equation. Let's see. Which is 10 times x. Now here's where I see mistakes in this method. You're used to replacing x. Pay attention that we solved for y first this time. Don't plug -9 in for x. Plug it in for y because that's the one we found. So 10x plus 2y. Instead of y, we're putting -9. So 10 times x plus 2 times -9 equals -8. Okay. Now, before we solve this, we're always going to want to multiply the number that was besides the y originally, and then we can start solving it. So we have 2 times -9. What does that give us? -18. And then I can bring everything else down. So -18, 10x minus 18 equals -8. Okay. So now, how do I solve for x? Yes, add 18 to each side. Okay, my 18s will cancel. I'll bring down my 10x equals, and what is -8 plus 18? 10. All right, how do I solve for x now? Yes, divide both sides by 10. And those cancel, giving me x equals 1. There we go. X is 1, y is -9. So if we write this as a coordinate, 1, -9. There we go. Okay. All right, before we do in one more example, do we have any questions about what just happened? Any questions? Okay, and more questions may pop up as we do more. Is anybody still writing this, or can I move it? Okay, I'm going to move it. All right, do another one. All right, page 2. All right, so more elimination. Let's look at, let's do 5x minus 16y equals 23, and negative x minus 8y equals 29. Okay. So we're looking at both equations and trying to think about which variable we want to eliminate first. We could do either one. Do the y's? Okay, so do we want to multiply the top or the bottom equation? Yeah, let's do the bottom one. So I have here, let's see, negative 8y and negative 16y. If I want negative 16y to cancel, what does this y need to become? Positive. Perfect, because we need them to be different signs. So if we want to make this negative 8y into positive 16y, what do I need to multiply? Negative 2. So I'm going to multiply everything by negative 2. Okay, so negative 2 times negative x. What does that give me? Positive 2x. Good. Negative 8y times negative 2. 16y. Good. And my equal sign, positive 29 times negative 2. Negative 58. Okay. So I've got that. What should I do next? Yes, now let's rewrite that other equation, stack them on top of each other, and then we need to add them together. Okay. So we'll just go down the line. We already know that our y's are going to be eliminated. That's why we did the multiplication. So I'm just going to start by crossing those off. The y's are gone. Now let's add everything else. What is 5x plus 2x? 7x. Perfect. I'll bring down my equal sign, and now I have 23 plus negative 58, or 23 minus 58. 35. Negative 35. Okay, perfect. So I've got 7x equals negative 35. What's my last step? Divide. We're going to divide by 7. Both sides. And the 7s will cancel, leaving me with an x all by itself. Bring down my equal sign, and now what is negative 35 divided by 7? Negative 5. Perfect. X equals negative 5. All right. So we solved for x. What should we do now? Plug negative 5 into one of my original equations. Does it matter which one I use? No, it doesn't. You can use either one. I think, what do you guys want to do? Top or bottom? Top one? All right, let's do it. So I am going to just rewrite down here 5 times x, because we solved for x, minus 16y equals 23. And since we know that x is negative 5, I'm going to put that in my blank space. 5 times negative 5. So once I've plugged in my x value, like that, where do I go from here? Perfect. 5 times negative 5, that's going to give me negative 25. Perfect. And then I'll bring everything else down. Minus 16y equals 23. What should I do next? So I'm trying to get rid of negative 25. How would I do that? Plus 25. Good. Plus 25. Plus 25. And that will cause these to cancel. So I'll bring everything down. Minus 16y equals 48. All right, one last step. What do I do? Yes, divide by negative 16. Okay, those will cancel, leaving me with y by itself. And now I have 48 divided by negative 16. Negative 3? All right. So we've solved for x. We've solved for y. What would our coordinate be? Yeah, negative 5, negative 3. All right, guys. Yes.
Okay, so just plugging it into the bottom equation on that place, negative x. You just do the negative parentheses, negative.
Yes. Yes, and that would turn that into a positive 5 minus 8y. Yes. Okay, guys, that's going to be the last thing we do today. I do have worksheets with problems like this if you want one to try on your own, but I will also pass those out on Monday. If you'd rather just go, you can just go. That's it today. No exit ticket. Just remember, everything that's due tomorrow is written on the board. Day 21, 22, and 23 exit tickets. If you don't know if you've turned things in, you can come and ask me and I can check for you. But I hope you all have a lovely weekend. I will.